The robot revolution has already begun. A new field of study called micro-robotics, which combines microtechnology with robotics, is quickly paving the way for the creation of robots that are little larger than a human hair. You did read that correctly. Numerous advancements have been made worldwide, ranging from microbots that can walk, fly, swim, climb, and crawl to those that can spot diseases, remove tumors, and carry drugs inside our bodies. Micro-robots that are as small as less than 1 millimeter have also been developed by scientists to further the march of these cutting-edge creations. Globally, engineers and programmers are continuously attempting to expand this discipline and create microscopic robots that are invisible to the unaided eye. All thanks to recent developments in computing, nanotechnology, electronics, and mechanics. Some of the micro-robots being created are proving to be highly useful tools, while others are being conceived and built as innovative concepts for future advancements in the micro-robotics industry. Here are the top 10 advanced robotics projects that will amaze you. These microbots are the product of excellent engineering and were created to address a variety of issues, whether in the military, healthcare, or engineering fields. Let's look at them now without further ado. Laser-activated microscopic robot. Researchers from Cornell and the University of Pennsylvania developed minuscule robots that include 4 electrochemical actuators that serve as legs in a basic circuit composed primarily of silicon photovoltaics for the torso and brain. These 40-micron broad, 40 to 70 micron long, 5-micron thick, laser-activated microrobots. These tiny machines are operated by firing laser pulses at various photovoltaics, each of which charges a different pair of legs. The laser is switched between the front and back photovoltaics to allow the robot to walk. Sea creature-inspired aqua robot. Researchers from Northwestern University recently created a lifelike soft robot that can move like a human, carry cargo to various destinations, climb hills, dance, etc. This miniature robot, which has 4 legs and functions in a water tank, is best suited for usage in aquatic settings. This tiny, centimeter-sized aquatic robot moves at a speed of 1 step per second and imitates the behavior of marine life. Its weight is over 90% water, so it can move without complicated machinery, hydraulics, or electricity. Instead, it is activated by light and moves in the direction of the surrounding spinning magnetic field. This microrobot's water-filled structure and embedded skeleton of straight nickel filaments are ferromagnetic, allowing for accurate and agile movement. Bio-inspired micro-robot. A group of researchers from the Max Planck Institute for Intelligent Systems, MPIS, in Stuttgart developed a tiny micro-robot that resembles a white blood cell moving through the circulatory system by drawing inspiration from white blood cells. This tiny robot has a shape, size, and range of motion similar to leukocytes. The drug delivery robot in the shape of a ball can endure the simulated blood flow. Every cell is covered, providing the best path for navigation. This microcontroller has a glass microparticle construction and a diameter of under 8 micrometers. A thin nickel and gold film is applied to one side, and anti-cancer medication molecules and certain biomolecules that can identify cancer cells are applied to the other. It can release the medication molecules and is coated with cell-specific antibodies. The microcontroller can move up to 600 micrometers per second, about 76 body lengths per second, in the laboratory. Ladle-like magnetic microbots. This tiny robot has the ability to melt, slip through bars to escape from a prison, reconstruct back into a solid state, and carry out tasks. The T-1000 character, the Terminator played by Robert Patrick, who could morph his way around solid objects before going on a murderous rampage, has been widely compared to the metal microbot, which is made out of liquid metal microparticles that can be guided and reshaped by external magnetic fields. Contrary to the movie, the creators of this robot feel that by accessing difficult-to-reach places, their invention might be beneficial, particularly in healthcare and mechanical contexts. Engineers Eun-hee Kim and Hong-soo Choi from the Daegu Daeongbuk Institute of Science and Technology in South Korea created rectangular robots with the help of their colleagues so that they could bridge the gaps between 2 different groups of cells. The small magnetic microbots, which resemble miniature Lego pieces and are 300 micrometers length and 95 micrometers wide, can connect brain cells, individual neurons, to form neural networks. Minuscule robots. Researchers have been working toward creating tiny robots that can maneuver through blood veins and deliver medications to specific parts of the body for years. Microrobots that can deliver drug payloads through blood arteries in people have been created by researchers at ETH Zurich. These tiny microrobots can move through our blood vessels and deliver medications to specific locations in the body because they are so small. The tiny robots are produced using a complicated 3D printing technology that interlocks several materials. Although metals and polymers have different qualities, both materials have advantages when it comes to creating tiny machines. Metal and plastic are bonded together as closely as links in a chain. Harvard Ambulatory Microbot, or HAMRJR. Microrobots that can deliver drug payloads through blood arteries in people have been created by researchers at ETH Zurich. These tiny microrobots can move through our blood vessels and deliver medications to specific locations in the body because they are so small. The tiny robots are produced using a complicated 3D printing technology that interlocks several materials. Although metals and polymers have different qualities, both materials have advantages when it comes to creating tiny machines. Metal and plastic are bonded together as closely as links in a chain. RoBeetle. RoBeetle is an autonomous crawling robot that weighs only 88 milligrams and is powered by the catalytic combustion of methanol. This tiny robot, created by researchers at the University of Southern California, employs an artificial muscle system to crawl, climb, and carry items on its back for up to 2 hours. It operates on methanol. The RoBeetle, which is 15 millimeters, 6 inches in length, has an artificial muscle system powered by liquid fuel, methanol, that has a 10x greater energy capacity than a battery of the same size. These tiny robot's legs are 4. Its front legs are connected to a transmission that is coupled to a leaf spring that is tensioned in a way that pulls the legs backward, while its rear legs are stationary. The robot's body serves as a methanol-filled fuel tank, and it is constructed in such a way that it may stand straight when at rest. A system with entirely mechanical components can control the flow of fuel thanks to its mechanical design. Magnetic T-Budbots. T-Budbots are biocompatible micromotors made from T-buds that were developed by ACS Applied Materials and Interfaces researchers to remove biofilms, release an antibiotic to kill bacteria, and clear away the debris. Due to electrostatic interaction on their surface, the small robots can include the antibiotic ciprofloxacin, enhancing their antibacterial effectiveness against the awful pathogenic bacterial communities of Pseudomonas aeruginosa and Staphylococcus aureus. T-buds from Camellia sinensis are porous, non-toxic, affordable, and biodegradable. Additionally, polyphenols, which have antibacterial characteristics, are present in the T-buds. All-terrain microrobot. A Purdue University team of engineers has created an all-terrain microrobot that is only a few human hair strands in size. This tiny robot can deliver drugs to people who have organs with uneven terrain, including the colon, by performing backflips throughout the colon. The all-terrain robot is too small to carry a battery, so a magnetic field from the outside powers and wirelessly controls it instead. The microscale magnetic tumbling robot is a millionth of a meter, or 400 by 800 microns, smaller than a pin's head. The microbot is propelled in an end-over-end or sideways tumbling motion by a continuously rotating magnetic field, which makes it possible for the microbot to move over uneven surfaces like bumps and trenches, which would be challenging for other types of motion. Robofly. Here is one last but not least called robofly. Researchers at the University of Washington have created this 74 milligrams flapping wing microrobot that can move in the air, on the ground, and on water surfaces. Compared to prior insect-sized robots created, this new one was constructed with less parts. This made the fabrication process easier. This robot's chassis is made of a single folded laminate sheet thanks to its unique design. In order to fly and hover like some insects, robofly uses its 2 flapping wings that are propelled by piezoelectric actuators. It uses its flapping wings to move and steer on the ground. The robot can land on water surfaces due to its small weight if it is outfitted with a set of 3-foot-like legs. The robot can move and maneuver on water after landing using the same idea that it uses to move on land. Have you not been awestruck by these tiny robots? Our list of micro-robots may not be comprehensive because additional innovations are undoubtedly occurring as we write this list, or we may have overlooked some of them, but it will give you a decent picture of where the robotics field stands today and where it is headed. To watch more exciting videos, subscribe to our channel and leave us a comment.